you can see here, you can see here G1 and G2 are connected in series. So step 1 in solution, amma, step 1, combining G1 G2 which are connected in series. You have already drawn this diagram, that's why I am not asking you to draw this diagram, isn't it? In the last class we have already discussed. Once again I am revising this. Okay, so combining G1 G2 which are connected in series, so you must write steps, step 1, step 2, step 3, step 4, like that. Okay, so step 1, so combining G1 G2 which are connected in series, so join G1 and so since they are connected in series, you have to multiply the gain values of those blocks. So multiplying the gain values of those blocks, you will get G1 into G2. Okay, so this is our step 1. Okay, so you have multiplied them. Later on, if you observe, this is the arrow mark direction of the signal in this path, and the direction of the signal in the parallel element is in reverse. That means this is a feedback loop. If you go to this smaller loop, here two small loops are there, isn't it? This is one loop, this is one loop. Okay, so let us see whether it is a loop or not. This is a loop because there is a return path. Current, not current, signal is flowing like this. From here it is returning back to the summing point. Here if you see, signal is moving from this branch point towards the summing point. From the same branch point it is moving to the summing point. That means G3 and G4, they are not connected, means they are not forming a loop. They are connected in parallel. Why? Because the signals of both the branches are moving towards the summing point. Okay, so since these two G3 and G4 are connected in parallel, they must be added up. So next step 2. Step 2, amma, combining G3, G4 which are in parallel. G3, G4 are parallel. Simply add the gain values of those two blocks. So G3 plus G4 you will get. Now it is very simple and clear block diagram. So in this block diagram, what comes to our mind is, if you see here, this is the smaller loop. Okay, so there is a return path here, negative feedback loop. So you have to reduce this negative feedback loop. Okay, since you have to reduce this negative feedback, this summa, this negative feedback loop. Okay, I will take red pen. It will be more clearer too. This is a sorry. Okay, so this is a negative feedback loop, amma. So it's a negative feedback loop. So when so negative feedback loop means this is G, this is H. So G by 1 plus GH. Okay, G by, if you want to reduce it, G by 1 plus G into H. So what is G here? G is equal to what? G1, G2. So G1, G2 by 1 plus G1, G2 into H1. Okay, so you will get this. Okay, so next. So here you will get this. Okay, next step, amma, step number 3. So you have reduced the feedback loop. Okay, in this step number 3, you have reduced the feedback loop. So when feedback loop is reduced here, so you will get this. Okay, and now what we can see here is this block is in series with this block. So you have to multiply this gain value with this gain value. Next step number 4, combining the blocks which are connected in series. You will get this. Okay, now you will get this. And if you observe now, signal will flow like this. Signal will flow like this from this branch point. Arrow mark is like this, means this is the arrow mark, means this is a, there is a return path. There is a return path towards the summing point, means this is a loop. Which type of loop? Negative feedback or positive feedback? It is a positive feedback loop. So since it is a positive feedback loop, you have to, you know how to determine the transfer function of a positive feedback loop. What is it? G by 1 minus G into H. G by 1 minus G into H. What is G value? This whole magnitude is G by 1 minus this 1 minus this whole magnitude is G, and 1 minus G into H value is H2. So you just that's what I have written here. If you observe here clearly, okay, you can further reduce it, simplify it, mathematical simplification. If you perform, you will get this is our overall transfer function of the system. Okay, anybody, if you want anything, you want to ask me anything, or you want to note it down, you can ask me. Do you want me to give 2-3 minutes to copy down? This is a problem. Nothing? Shall I proceed?
Okay, ma'am.
Shall I proceed?
A bit slow, ma'am.
Okay, I will go a bit slow. Okay then. Okay, Amma. So I'm going to next problem now. Okay, you just copy it down. Copy it down, Amma. All of you copy it down. You want me to show second slide? Somebody is asking second slide. Okay. This was my first slide. Second slide, Amma. Ido, Amma. Did you check your mail? All of you, I have forwarded before these problems, whatever content that I have discussed in the class, I have already forwarded the PPTs to your classroom. In your classroom, what is that? Classwork. Okay. So I have, to that mail ID I have forwarded, you go through it. All the PPTs have been forwarded to you. Okay, this is our second slide. Is it okay? Shall I go to second problem? Okay, I will go very slowly. You people copy it down. It is very, very important. Okay, don't neglect. These problems are very, very important. Okay, see, Amma, reduce the block diagram. Reduce the block diagram shown in the figure and find C by R. C means output. R means input. C by R means what? Transfer function. Okay, so this is a block diagram. Okay, so this block diagram seems more simpler when compared to your previous block diagram, but this is more complicated when compared to your previous block diagram, Mama. Okay, so when compared to your previous, it is more complicated. How, I will tell you. Okay, did you draw the diagram? Anybody can answer? You can even message me. I can see in my screen, I have two screens. Did you complete drawing this diagram, draw chaser? If you have completed, just inform me. Did you draw this? Yes? No, ma'am? Okay, Amma, draw it quickly. Draw it quickly, make it fast. I'll drink water and come meanwhile. If completed, just in. If completed, inform so that I will change the slide. You can ask me anything if you want. Completed? Yes? Okay then.
Yes, completed.
Okay, very good, very good. So if you look at this diagram, I have to reduce it, isn't it? I have to reduce this block diagram. So is there any smaller loop? By looking at this diagram, it seems this is a smaller loop, isn't it? This is a smaller loop. It seems as if. But in this loop, there is an obstacle here. This is an obstacle, isn't it? If this branch point was not there, if this branch point was not there, I might have simplified it. It seems as if it is a negative feedback loop. Okay, it seems as if it is a negative feedback loop. But there is an obstacle. So what I can do is, I can move this branch point here. Okay, I can move this branch point ahead of this block. When I move a branch point ahead of a block, what happens in this parallel path? Okay, and another block is introduced. It can be, its magnitude will be related to this G1. It can be G1 or 1 by G1. You have to tell me why, because I have already discussed the rules. So if I move this branch point ahead of this block, so this feedback loop can be easily simplified. Let us see what I have done. So I have moved this branch point ahead of this block. Okay, so branch point, whether this branch point is here, okay, at this point or at this point, it doesn't matter. Why? Because no element is there here in between. Whether it is here or here, it doesn't matter, it is same. Okay, so for simplification, I have moved this branch point here. Okay, I have moved it here. Okay, so I am moving the branch point ahead of this block. So a branch gain, okay, a gain value which is related to G1 will be added in this. Okay, in this it will be added. What is it? 1 by G1. 1 by G1 will be added. Okay, so in order to draw this, if I go on writing like this, it will be confusing to you. So I have moved this branch point to this. Wait, highlighter. I have moved this branch point to this area. Okay. So a magnitude of 1 by G1 has been introduced. Again, value has been a block. An additional block is added here. Okay. Now, see. Now what comes to our mind is smaller loop. This is a smaller loop. That too, it is a negative feedback loop. This is a negative feedback loop. Okay. One thing I would like to tell you is no need to draw these two diagrams. You can draw this only this diagram is more than sufficient. Okay. If you are able to draw this only this diagram is more than sufficient. Why? Because it has mentioning these arrows and all is not required, but your wish. If you have patience and if you are fast enough to draw, you can draw it. So this branch point is moved here. So one more block is introduced here. So now by looking at this, first thought comes to my mind is that these two elements are connected in series. So simply I can multiply these values. Okay. And one more thought comes to my mind is this has since I have moved the branch point here, this becomes a negative feedback loop. I can reduce this negative feedback loop. You can perform 2 steps at a time in your next step number 2. Step number 1 is moving the branch point after the block. Okay, I have moved the branch point after the block. That is step number 1. In step number 2, I can write simply combining the cascade elements. Okay, and remove the feedback path. Okay, eliminating the feedback path. Okay, I am eliminating the feedback path. I can write, or simply I can combining the cascade element step number 2. In step number 3, eliminating the feedback path. I can do like that. Okay, did you complete this? I am talking a lot so that you people can copy it down. No need to draw this first diagram. Directly you can draw the second diagram. Okay. So no need to mention arrow and all. I am changing the slide. If you have not completed, inform. So step number 2, I am eliminating the feedback path. I have done both the operations at a time. So one is eliminating the feedback path. This is my feedback path. No need to draw this diagram. You can draw this diagram only. Directly you can draw this diagram. If interested, your wish, If you are able to fastly draw, you can draw both the diagrams. Okay, combining the blocks in cascade. So G1 by G1 and G3 are in cascade. So I will multiply these two values. So G3 by G1 I will get. Okay, and this is a negative feedback loop. Negative feedback loop means I have to reduce it. Okay, so I have to reduce it. So what is it? G1 by G1 by 1 negative feedback means plus G1 into H I will get. Okay, G1 by 1 plus G1 into H I will get. Okay, so combining the cascade blocks. So now this is my next block diagram. Okay, now by looking at this, this loop comes into my mind. Okay, this loop comes into, is it a loop? Let me check. Loop means it should have a return path. No return path means it is not a loop. See, signal is flowing from this branch point towards the summing point. Signal has started and moving from this branch point in this path towards the summing point means this is not a loop. This is a parallel path. Okay, so this is a parallel path. This is a parallel path. Okay, this is a parallel path. Parallel path means what you have to do? Simply you have to add the magnitudes. Okay, you have to add the magnitudes means G2 plus G3 by G1. You can write like that. Okay, I hope you have drawn. I hope you have drawn it. Yes or no? Shall I change the slide?
Yes, ma'am.
Okay then. So eliminating or combining the parallel blocks. So I have combined the parallel blocks. Step number 3, Amma, you must write these steps. You must definitely write these steps, Amma. So I have drawn additional diagrams for your sake so that it will be easy for you. No need to draw this. No need to draw this. You draw this. You draw the second diagram. It is more than sufficient. But if you are interested, you can draw this. If you are interested. If you are interested, otherwise no need to draw. Okay, so these two are connected in parallel. So G2 plus G3 by G1. Now, next step, I need not tell you. Step number 4, I need not tell you. You yourself can tell. So these two blocks are connected in series or cascade. So step number 4 is combining the cascade blocks. Next step is combining the cascade blocks. So if you combine the cascade blocks, so simply you have to multiply the magnitudes or the gain values of these two blocks. Okay, I'm changing the block, changing the slide. Okay, so where is my another block? Okay, so I have set the animation for this, it seems. That's why. Okay, so next step, I will get like this. Okay, so see, I have combined these two, multiplied. So I have whatever mathematical simplification that I have to do for these two when I multiply these two terms. Okay, after performing mathematical simplification, I will get this. I will get this. Okay, so I will get this. Okay, so this C by R is this value. Just copy it down. Okay, from this. Oh, 1 minute. Now I am satisfied. Okay, copy it down, Amma, quickly. I hope you are drawn till here. Rest of this is. If you have any doubts in this problem, just inform me. In the second problem, anybody? If you have any doubt, ask me. If you complete, inform me so that I can go for the next step number 3. Step number 3, what? You want to copy it down? Do you have any doubt in step number 3? Step number 3, copy it down. Change this slide, okay? Step number 4. Copy it down, Amma. See, this is a problematic subject. This is a problematic subject. So all of you don't neglect the problems. Problems, if you know the concept, you can play with these problems, huh? Like anything. They are very, very interesting and they are very, very interesting to solve. If you complete inform, I will go to the next problem. See, no need to write all these simplification. Directly you write down this. You can do the simplification later on your own. Okay. Anyhow, I will forward all these slides to you. Don't worry. But if you put pen on the paper, then only you can understand what is going on in the class. Simply if you are listening without writing, okay, simply if you are listening without writing, then it is of no use. Shall I go for the next problem? The people are still writing? Okay, yes? Okay then. Okay, Amma, next problem. Same, you have to determine the transfer function of the given block diagram. So see here. So my output is y of s, input is r of s. So what I want is y of s by r of s. So what is my main aim? My aim is to determine y of s by any issue. Are you able to hear me? Any issue? If there is any issue, tell me. So you want to determine y of s by r of s. So by looking at this diagram, it's a weak diagram, isn't it? What comes to my mind is G1 and G2 are connected in cascade, yes, isn't it? So I can combine these two. Okay, they are connected in cascade. While I'm talking, you people copy down. Huh? That's why without changing the slide, I can't sit quiet. That's why I'm continuously talking. Okay. So G1, G2 are connected in cascade. And if you see, I can see something here. G3 and G4 plus towards the summing point means G2, G3 and G4 are in parallel. So in step number 1 itself, I can perform two operations. One is combining cascade blocks. Okay, I can take a pen. I can combine these cascade blocks and I can remove this parallel path. Okay, I can remove this parallel path in step number 1. I hope you people might have drawn meanwhile I'm talking. Draw quickly. Draw quickly so that I will go for the solution. These signs are very important. Signs plus, minus and all. They are very important. Completed? I'll take the snapshot while you people are copying it down. Okay, then I'm changing the slide. Okay, ma, step number 1. Okay, as I have already told you. See, G1, G2 are connected in series. So I have joined them. G1 into G2 I will get. G3 and G4 are in parallel path. So G3 plus G4 I will get. So combining the cascade blocks G1 and G2 as well as eliminating the parallel path of blocks G3 and G4. Okay. So, oh, okay. You people copy it down. Meanwhile, I can't sit ideally. I will do something. Copy it down, Amma, all of you. Copy it down. Completed? Okay. So I have combined this cascade blocks and eliminated the parallel path. Now what comes to my mind is, I can see a feedback path here, a smaller loop with a feedback path. I can eliminate this feedback path in the step number 2. Okay, this is a smaller loop, isn't it? I can eliminate the feedback path as well as, if you see here, there is a branch point here, and here there is another loop here, but one branch point is in between here. So I can either shift this branch point, sorry, I can shift this branch point this side, or I can shift this branch point this side. It's my wish. So if I'm able to shift this branch point this side, I will get a negative feedback loop. Okay, I will get 2 negative feedback loops, which I can eliminate. If you have drawn this diagram, I will proceed to the next slide. Did you complete? You are not responding, so I'm moving to the next slide. So see here, step number 2. In step number 2, Amma, I am eliminating the feedback path of G1, G2 and H1. This is it. Okay. So it's a negative feedback path. So I will get G1, G2 by 1 minus G1, G2, sorry, not minus, negative feedback. So 1 plus G1, G2, H1. G1, G2 by 1 plus G1, G2, H1. I will get. Okay. So here I have moved the branch point after G5. Okay. So you can move either way. Either you can move branch point this side or you can move branch point the other side. So when I move the branch point, which branch point? The lower branch point. This branch point is moved ahead of the block. So one block will be introduced here. That block is, one block will be introduced here. Here, wait. So one block, when I move this branch point to here, I will get 1 by G5. Okay, I will get 1 by G5. Okay, so when I get 1 by G5, so 1 by G5 is in series with H2. So I can simply multiply H2 and 1 by G5 when this branch point is moved ahead of this G5. Okay, so I will get, next slide you can see H2 by G5 since the branch point has moved from here to here. Okay, since the branch point has moved from this point to this point, an element 1 by G5 was introduced here. It was introduced, it came into existence here. So that 1 by G5 is multiplied with H2. So when it is multiplied with H2, it will become H2 by G5. Okay, it will become H2 by G5. So you will get like this. Okay, step number 2. You can call branch point as takeoff point. Okay, so now this is step number 2. I think it is clearer to you. Now step number, what is the time? 42. Okay, I will complete this problem and I will conclude. So if you see here, these two elements are connected in series. So G5 can be multiplied with G3 plus G4. G5 into G3 plus G4. Next step is combining the cascade blocks. I hope you people have already drawn this. I'm moving to the next slide. I'm going very slowly. I'm trying my level best to move as slowly as possible. I'm teaching very slowly. I'm going to step number 3, Amma. Combine the cascade blocks. So you will get G5 into G3 plus G4. Next step. Next step, Amma. Okay. I'm giving sufficient time to draw. I hope you people have drawn it. Now, combining the cascade blocks. Now, if you see, there is a smaller loop here. In this smaller loop, the signal goes like this. From this branch point, it is returning back. Means this is a negative feedback path. Negative feedback path. Okay. So the returning path is the feedback. This is the main path. So So this is your G by negative feedback means G by 1 plus G into H. Okay, next step number 4. Step number 4 is eliminating the feedback path. No need to write G3, G4, G5, whatever terms are there. Combining cascade blocks. Simply if you are able to write combining the cascade block, that is more than sufficient. No need to write. I have written here, but no need to write. So next step number 4 is simply I will eliminate this feedback path. What I will get is, I will get one block here, there is another block here. So those two blocks are in cascade. Simply I will multiply those two. Later on if you see, signal goes like this and it is returning back. It will become a positive feedback path. So I will eliminate the positive feedback path. So I will get the overall transfer function of the system. Okay. Okay, next I'm changing the slide. Step number 4. Step number 4, Amma, eliminating the feedback path. So eliminate the feedback path, you will get this. Okay, you will get this. So you have to multiply the next step number 5 is combining the cascade blocks. Draw this. Okay, already 45. Already it has crossed 10:45. Make it fast. If you complete, I will take the attendance. Okay. So next step, Amma, and no need to wait for me at all. Okay. So next step number 5 is combining the cascade blocks. Okay. I'm going for step number 5. So combine the cascade blocks, you will get like this. Next is eliminating the positive feedback path. So this is G by this is H. Okay, this is G, this is H. So G by 1 minus G into H. Step number 6 is eliminating the positive feedback path. No need to wait for me if you have understood the concept. No need to wait for me. You people can proceed. Okay? No need to wait for me. No need to copy it down. You can solve on your own. Okay? Next step number 6. See, eliminating the feedback loop, positive feedback loop. So here I have not written positive, but it is a positive feedback loop. So if you remove the positive feedback loop, you will get this. So what is y of s by r of s? This is what you will get. Okay, just note it down. I will call your roll numbers. Okay, to take the attendance.